A different way to approach these problems is to understand how these radicals in some ways are like division of exponents. It's similar to dividing the exponents. And what we can do is say, okay, how many times does 4 go into 6 and what's left over? So if this is called the index of the radical, goes into that power at all, then we're going to go ahead and do that division. I think everyone knows that 4 goes into 6 one time, and there's a remainder of 2. So what I'll do is I'll know there'll be a 2 to the first on the outside, and since there's a remainder of 2, 2 squared on the inside. I know that 4 goes into 7 one time. So that means it's x to the first on the outside, and then there's a remainder of 3. So it's x cubed on the inside. 4 goes into 10 2 times, and there's a remainder of 2. So w squared. And that's how I know my final answer is going to be 2xw squared, fourth root of 4x cubed w squared. As we do more of these problems, if you think about what's actually being said, it'll make more sense that this radical is like dividing the exponents. If they go in evenly, great, and if they don't, then the remainders are left inside the radical. If that's kind of jiving but not 100%, go back to examples that actually make sense. Like, for example, when we were talking about things like the fourth root of x to the 20th. And we know that a fourth root means multiply something by itself 4 times to get x to the 20th, and x to the 5th is what makes sense. So that would be x to the 5th. It's taking that power, dividing it by that power. And if it doesn't go in evenly, the remainders remain inside.